through there.
All right. So I think we are live now on YouTube and LinkedIn as well.
Hmm.
So guys, if you can see us or if our microphones, everything is correct, let us know in the comment section so that we can continue with the session. So okay, it's on LinkedIn too as well. I got a notification that we are streaming there. So
Hmm. Sounds good.
I think we might have to wait a little bit for a few people to join, and then we'll take it out from there.
Yeah, yeah, sounds good. Good stuff. It's a bit of time.
Okay, so I'm Abdul Nigeria. I'm from Nigeria. I can hear you crystal clear. Okay, guys, good, good. Thanks a lot. You can do share the live in your group so that we can have a lot of people watching this together. I think we are clear. We are clear now. They can hear us.
Sounds good. All right. Great. Great. Mhm.
Okay, so guys, we'll start in just some few minutes. So waiting for some few people to join, then we can start it up. I think we can start, right? Because this is recorded, and anyone who later join will have access to also view whatever we've done. So I
Mhm.
think the wait is over now, and we can just get right into business. So that's it. With that being said, let's just start with a brief introduction, and then we'll look at the main agenda for today. All right, guys. So, as usual, you know me already. I'm Felix Sam Nano, and I do a lot of AI stuff on this channel. So today we'll be looking at the Florence II model from Microsoft. We'll be looking at in-depth understanding about it, how to set it up, and how to also utilize this model. On a personal terms, I think this model have a huge or a lot of capabilities. And even right from this particular live stream, I'll be making a lot of videos about this model as well. All right, so with me here, I have my friend, Mr. Yan, Netayan. Netayan is um, computer vision engineer having his internship currently with RoboFlow. So he has gained a lot of experience over the years, and he will be sharing with you guys some of the things he has learned and also show you how you can set up and use the Florence 2 model. He will also tell you how this model works, what the model can do in general, let's say the capabilities of the model. So now, yes, to Mr. Netayan for his quick introduction. Then we can continue from there.
Yeah, so as Felix said, my name is Nathan. I am currently a machine learning engineer intern at RoboFlow. And with that internship, I've gotten a ton of hands on experience with Florence too. And so I've been working on it for a ton of different things, and in today's session, I'll be showing you how to use Florence 2 for instant segmentation and some of the high-level explanation of how the code works uh, for the Florence 2 model.
Oh,
But yeah,
okay,
I
okay.
think
Yes, I think that's great. So you guys get to know Nathan. You guys can connect with him. He's on LinkedIn. He's making a lot of posts. I've learned a lot from his posts. He's always building projects and sharing his whatever he has learned so far with RoboFlow, whatever he has the experience he has gained in recent years. And I love his post. So you guys should do well to follow him. At the end, I'll drop his link in the session. But from that, let's quickly look at the agenda. We are covering a lot of things today, including how the model works. That will be done by Nathan. We'll also look at that into detail, and then from there we'll also look at how to set up this model and how to use it. From there, we'll accept some questions from you, the viewers. If you have any doubts, if you want to know something personally about myself, about Nathan, about whatever he's coming to teach, we'll be accepting those questions and we'll give you answers to that question. So I think that's quite the agenda of today. So from here, I'll just hand over to Nathan, and then he will continue with explaining how what this model is. If you have no idea about this model, he will explain the model, tell you how this model works, and he will continue from there. So Nathan, over to you. You have the viewers now; they are listening to you.
yeah, for sure. Let me share my screen.
I
So,
think that would be good. That would be good.
yes. So first, I'll just talk about. Can you see my screen, by the way? Oh, you can. Okay, good.
Yeah,
First, I'll just talk
guys,
about
let us know if
why.
you can see his screen. Let us know in the chat if you can see Nathan's screen. I think I made it visible, but let the viewers give us some comments if they can't see it. Is that visible, guys? I'm waiting for your comments on that, or let me quickly check that. So I'm checking that. Okay, I think so. You can continue.
Yeah, sounds good. So essentially, Florence 2 is a multimodal transformer model made by Microsoft, and it follows essentially a lot of the same structures of a lot of the computer vision models that can do a lot of different things, such as polygemma. But the reason why Florence 2 is so good is because of its data. And if you look at its parameters, you can see that it has a lot less parameters than a lot of its competing models, as you can see from this wonderfully made graphic by Peter. Anyways, the reason why it can have such little parameters is because of its really, really good input data and training data. And that's why Florence 2 is such a strong model and is so currently relevant. And as you can see from the screen, Florence 2 is actually able to do a ton of different tasks. If you look at ChatGPT as a comparison, you can see that ChatGPT can only do really three things, which is captioning, visual question answering, which is answering questions on an image, for example, and object character recognition, which is just getting the characters on the screen. So these are really the only tasks that ChatGPT can do, which makes sense since it wasn't really designed for images, but Florence 2 can do a lot more. Florence 2 can do all of the mentioned tasks, as well as detect specific objects and segment specific objects, as well as, of course, ground some stuff. On top of all of that, it's also open source, which means that you can use it and deploy it anywhere, anytime you want, which is really, really good. And compared to other open source models, for example, such as Polygemma, it's still better than those models, which is very surprising. First of all, is because it has a lot less parameters. As you can see, it only has 230 million or 770 million versus 3 billion, which is a lot less. That's exponentially less parameters than a model that also is really strong. Secondly, it's a lot faster. It's 4 times faster than Polygemma and a lot faster than Lava 2, which both are really powerful models. And this is all because Florence 2 has really good training data, which they made through, I think, some model that got to parse a lot of the data and label a lot of things automatically. You can research that in the paper. I think they explained that really well. But that's, I think, the beauty of Florence 2 and how useful it is in terms of what specific tasks it can do, as well as the speed and parameters that it has. So overall, the reason why Florence 2 is so significant is because it has less parameters than a lot of these big models. It's able to do a diverse and a lot of different tasks. It's open source and it's actually pretty fast for how big the model is. And this YouTube video is available on RoboFlow, so I highly recommend you guys to check it out. It explains how to fine tune Microsoft's multimodal model Florence 2, and it's just a great video in terms of learning how to fine tune the model. But today we're not going to talk about how to fine tune Florence 2. We're actually just going to talk about how to really run it on specific tasks and just use it as the model it is. And so we can just check out this Google Colab first, which I'll just explain how instance segmentation works using Florence 2. And if you want to access this Google Colab, it is on one of the RoboFlow blogs. And if you go on RoboFlow notebooks, you can actually check out a better version of the notebook here, which is the fine-tuned Florence 2 on an object detection dataset, or run different vision tasks with Florence 2. So these two notebooks I highly recommend. You'll learn a lot about the model. But let's go back to this and let's see what Florence 2 can really do with instance segmentation. And here we're just going to use Hugging Face to really deploy everything. I'm not going to run anything because it's pretty slow and I don't want to wait for a lot of the stuff to run. But as you can see, we're just going to get the Florence 2 model first at this checkpoint, and then we're going to get the model using Hugging Face here, and then get the processor too. And then after that's all done, it should be pretty good. And now we can actually get to the juicy part, which is how to actually run an example. And so what it actually does is it takes in a task prompt and a text input. And since we're doing segmentation, the task prompt is going to be segmentation. So if you look at an example, it will say referring expectation expression segmentation versus the text input, which is going to be the backpack for this example. But the text input can be anything for any image, which is really, really cool. After we get the prompt, which is those two added together, we get the inputs from the processor we previously defined, and we generate the model's predictions. And then after that, we decode a lot of the generated stuff and we parse it. And that's kind of a really, really high level example of how it works, but it's not too interesting for now. We'll just move on to how to actually segment a lot of this stuff. So actually, after getting this function and running it, we use supervision to actually graph out the annotations because this doesn't actually give the actual annotations. This will give the, I guess, text version of the annotations. So we're going to use RoboFlow supervision to actually graph everything out. I also highly recommend you guys check out supervision because it's super helpful in terms of a lot of things computer vision related. And we're just going to get the first image here, which is just a dog. If we want to click on this, it's just a dog and a guy. And so the first thing we're going to try to find is going to be the backpack. And using referring expression segmentation, we're able to successfully get the backpack, as you can see. And this one is not too impressive with the model, as a lot of other models can actually do this. But what's more impressive is this. If we go down here, we can see these are players in a soccer game. I don't know which soccer game, it's some soccer game, but it's pretty cool that if I put in ball as the text input, it's actually able to find the ball. And as you can see in the corner, it's able to detect it in the top right there. And so that's the magic of Florence 2. Even without Sahi, which can really help with these small object detections, it's still able to detect the ball, which is very, very exciting. And if you want to try out different task prompts with Florence 2, which is very, very doable if you just go to this notebook, which says for vision, different vision tasks, which you can get, of course, in RoboFlow notebooks, you can do a variety of things, such as object detection, which it does really well here. As you can see, it detects even the coffee table, it detects footwear, it detects the person over here, which is very surprising as that's only the leg. And it detects a bunch of different things, which I won't get into, but you can go check that out yourself. Anyways, it uses the same function that we defined from before. This is the exact same one as the one in this notebook. So you can use that. And of course, this is the task of a caption for this image. And if you look at it, it will say a man holding, or a man sitting in a chair holding a dog. And there are different varieties of this caption. So there's a detailed version and there's a more detailed version. So there's a ton of different things Florence 2 can do outside of its usual VQA, OCR type stuff. And on top of that, it can, of course, do caption to phrase grounding, which actually just grounds the stuff, which is very, very interesting. But I won't ramble too much about the whole computer vision model. You can check a lot of this stuff out. It's all super, super interesting. There's a ton of different vision tasks that it's able to do, and this is all using only one image. So if you want to use your own image, feel free to just replace it with the image and just copy this notebook, which is provided in RoboFlow notebooks on GitHub. But yeah, I think that's a quick breakdown of how Florence 2 works.
Interesting. Thanks a lot. I think I've personally learned one or two things from the model, and I think it's looking great. And for you guys, the notebook, the links to these notebooks will be shared in the video description. I'll personally get them from Yan, and also some links to RoboFlow where you can get access to this notebook and try this model out yourself. I think for now, when it comes to computer vision, when we talk about a model which have a lot of potential and can do a lot of stuff, I think Florence 2 do stand out. Because looking at the whole stuff that a single model can do, normally these stuffs are done by different or separate models. Let's say object detection, we have object detection model. If it comes to image captioning or video captioning, we have those model which are also separate. But with Florence 2, it combines all these models together. So I think it's quite amazing. It's very good, and it's something you guys should look out or watch out for. I think it can also do segmentation as well. We just give it a test prompt and it's going to do that. So it's a great model overall from Microsoft, a single model which is able to do captioning, detection, segmentation, and so much more. I think that's great. So guys, for now, if you have some questions, you can leave those questions for us. Mr. Yan is ready to answer you. I myself will be able to answer you. And as I said earlier on, I'll also drop many videos on this particular model because from personal, I know this will have a lot of capabilities, which I'll show you guys how it works. So someone is asking, Mr. Lim is asking, does it work with videos as well? Mr. Yan?
I see. So, in terms of videos, I think you'll have to get each image frame by frame. I think like currently the standard is just getting images frame by frame is probably the best way to do that. Even if you use, for example, like a video model, I don't think the accuracy will be as high as like if you just get images frame by frame using YOLO or whatever. But yeah, I think if you want it to work with a video, you'll just have to separate the video into specific frames and then just mash them together in the end product. But yeah, it should work with video if you, I guess, Go for
Okay,
it, my
so
friend.
I think maybe if you join earlier to Mr. Yan do share the model weight. So by looking at the weight, if you have a capable machine that has a lot of computational power, I think you can run that in a loop using like OPCV for instance, or supervision for instance. You can run that with using your GPU in a loop, whereby I think a video is just iteration of images together. So when you run that in a loop and the loop continues, you can see how it will perform on your video. But I think that is computationally expensive. So another option is to maybe cut these images or write a simple script that will be able to cut this video into sessions or smaller sessions, and then you will use those images to test the model. Okay, so I have another question here. How good is it for derma images such as segmenting acne?
Yeah, I mean, I think it will depend on the training data. If it had, for example, high quality, maybe face data,
Okay.
if there was like any of that stuff in the model. But I think generally that should be able to be captured if you want to capture acne segmentations. But I don't know. So you got to maybe try it out using the RoboFlow notebook. So if you just search it up, go to the Google Colab, and then literally just replace the image that is there. You should be able to use any of the segmentations or prompts there, and then you'll be able to do something with that. So go try that out. I think it should take less than 5 minutes. It's pretty simple. And Google Colab, I think, uses the cloud, so you won't really need to use anything locally. So yeah.
So another question from Mr. Robert. Mr. Robert is asking if the model can be quantized. So that maybe, since I know why this question is coming, because we said maybe it's heavy and they can't run it on video file. So most people like to quantize this model to reduce the size and be able to run it a little bit faster. So is the model has the capability to be quantized since it's open source too as well?
Oh, yeah, yeah, yeah. The model should be able to be quantized. Um, I'm not sure if we have any tutorials on how to do that, but I'm pretty sure it can be quantized. Yes.
Yeah, so that the answer is yes, but as for now, Microsoft didn't let's say release any documentation on how to quantize this model. They just have done that for maybe pre-training your own data set, and also they've given you the model as open source. And I think this model is in not so long, so that those things will follow suitly. And after that, we will update you guys on how that also works. Okay, so there is another question here. Someone is asking, um, what advice you have for a beginner in computer vision? What's the advice for a beginner in computer vision?
Hmm. I'd say just to learn probably the fundamentals. I think the fundamentals are pretty important. And then also try to explore a lot of the pretty cool uh, new technologies like Florence 2. So I know there's a few recently released models such as SAM 2 and I think Apple's 4M. Those are really cool models that you should also check out. And yeah, just learn better fundamentals, get a sense of how transformers work, and just try to up your technical ability. And I think that's probably going to be the main advice. Uh, Maybe get better with math too, because a lot of math
Exactly.
is needed. Yeah. Mhm.
Okay, so someone is asking, can you show again the command to install Florence 2? I think
Yeah.
okay, maybe you go ahead
I,
and show it.
it's not really a command, but you just essentially install here. So it's just you get it the model on Hugging Face, and then you use this. So it should be the same as the model here. As you can see, checkpoint is here, and the only difference one is the device. He turns it to CUDA because it will run faster. I didn't do that, but yeah, this is the checkpoint, and just take it from the notebook.
Okay, so there are questions coming in. Could you please give more insights on model architecture? How is it better than other equivalent models in the domain? Perhaps explain dual attention vision transformer.
Hmm, that's a good question. I think uh, in terms of Florence 2, there weren't any
Is in the
major
research paper.
model.
That is in the research paper. I think we are going to cover here today. So for that one, I don't think we are going to cover because that's in the research paper, and I'll share that in the description as well. Because Microsoft have explained that so well that you can understand, and whatever you are saying there is right in the paper. Attention.
Yeah, but hello. Oh, hmm. Okay, I'll try to give, I think, my opinion on the matter. But in terms of the model, oh, sorry.
Embeddings. Don't worry. We have visual embeddings and what test location embedding. So these are the two types of the embeddings they have done. So for the images, they have encoded these images and they have gotten the visual embeddings from them. And for the text, they have also done a test location embeddings from it. So from there, this goes to a transformer encoders, okay? And these transformer encoders, from there, they generate the total tokens together. That's combining the visual embedding and test location embedding together. So that's where they get this model. So based on your instruction, based on your test, this model is able to find its way out to provide the answer for you. And all these are in the papers. They've done a really good job. I've just read this paper, and I think by reading, I don't have to think too much. I'm able to understand the technical background about about the paper. So you guys, I'll share that with you guys, and you'll be able to get it right from the start.
Hmm. And
All right.
one other note on that question, uh, I don't think there was any major model architecture breakthrough. I think it was just
Yeah,
mainly high quality data. So they
exactly.
used a lot more high quality data, which helped it lessen the parameters. And because of the high quality data, it was able to use less parameters and still have a lot of the state of the art accuracy and do a lot of the capabilities that it was able to do.
Oh, okay, okay. And also, I think they've done a great job with the image annotation as well. So they've used special models to do the annotation, and that also speed up their process on in doing it. So in the paper, they were under data annotation, they have initial annotation with specialist models. So they didn't let's say do it all by their hands. They've used some existing models in doing that as well. So for your question, that's it. We'll provide links to these resources in the description as well for you guys. Any other question? I think for now there is no new question. I think we are cool. All right. No new question. Let me check on LinkedIn if we are having any question as well. Guys, if you have any question, kindly drop it off. Okay, I think we don't have any new questions. So I think that's it. Nathan, you can give your final words and your closing remarks about this. Then we are 30 minutes into it already. Then we can bring this live session to an end. Also, guys, if you have any question later on, kindly put it in the comment section. Nathan will also glance through there and make sure he answers your questions as well.
Yeah, I think overall, I think the key takeaways in terms of the Florence 2 model is that it is really, really strong. I guess that's a pretty basic way of saying it, but it's able to do a ton of different tasks that I think no other model has been able to achieve that many tasks. Like it can do captioning, it can do detection, it can do segmentation, it can do grounding, it can do like almost every single object
Every
detection
single
or
one.
like text image task, I guess. It's also open
Exactly.
source, which is really,
which is
really
great.
good.
It's
Mhm.
great. All right. So
And
before we even go, someone, but you continue. Someone have dropped a question, which I think this one is very interesting as well. So the question is so should we stop learning YOLO and focus on Florence too?
yeah, so I think the two models are pretty different fundamentally.
I think
YOLO
so.
is Yeah, I think YOLO is pretty much for just
Object
object detection.
detection.
Yeah, like real-time object detection. So the use cases are a bit different because, as you know, Florence 2 only runs on 4 FPS, so it's not really real time.
Yeah.
But Florence 2 is also like a vision language model, so it's like able to do a lot of different things there too. But yeah, two models, pretty different use cases and different like ways of working. It depends on what you want to go into. If you want to like learn more about how to make vision real time, or if you want to work more with text and vision, I guess it really depends on your use
Use
case.
case. Yeah, so as I said, it depends on your use case. Yeah. So YOLO models are the main work for YOLO models are object detection. They are good with detecting objects, and for them, because they are not doing a lot of tasks apart from object detection, they are very lightweight and they can run in real time. So you can run them on CPUs and GPUs as well, and they can be employed in edge devices, which makes them really, really good for a lot of applications. For instance, when you have a Raspberry Pi right now, you can easily run some of these YOLO models on them, and this gives you a whole lot of capabilities. Like you can use that Pi and run it in a remote area, or let's say you want to use that in a robot or something. That gives you a lot of freedom. Whereby the Florence model is kind of very big. 4 FPS is not enough for any real world application. In my case, I think. So for that, you may consider, maybe it depends, it really depends on the use case. When your use case have to do with something that maybe, I think captioning, for instance, you may depend on Florence too, whereby you're sending the image, it tells you what is going on in the image. And guys, stay tuned, because I'll have a tutorial with you guys on how to use this Florence 2 model. It's being hosted on Hugging Face, so I'll just teach you how to use it. It has ton of functionality. With even captioning, you have different levels of captioning. So I'll take you through all of that, and all of the other cool stuff this model can do. And there are different variations of this model too as well. So we have the large, we have the base model, and so on. So I'll take you through that one as well, in a separate tutorial. So I think that's it. That's it. It has a lot of functionalities which I'll take you guys through. And to conclude, this model will be able to also give you the labels. So I think it can give you labels and also the points. Okay, so let's say it can give you, maybe you give it an image whereby it segments that image. It can give you the segmented points. Okay, so with those points you can do a lot of things. You can use those points in your own code to uh, get that particular region around the segmented area. So it gives you a lot of flexibility and freedom, and all you need to do a lot of stuffs. And if it's not working on your data well, you have the option to also fine tune it. So that's it, guys. That's it. I think we don't have any more question. There is no question as well. So we'll be bringing this live session to an end. And guys, we thank you so much for tuning in. It has been a good session so far. And in future, I'll bring you more sessions like this. Some will be projects, some will be maybe our experiences, and a whole lot more. So expect more of these sessions as we proceed. Okay. So that's it. Do you have any other words? Do you have something else to say, Nathan?
No, I think you summed it up pretty well. I think we're pretty good.
Oh, okay. So that's it, guys. Thank you so much. We also thank you, Mr. William. You said, well, congratulations for this live session. We also congratulate you for joining in as well. So thank you, guys, and that's all for today. So now we said, okay, bye bye, and we'll catch you guys up in another live session. Before that, if you have any question, leave it in the comment section. We'll address it. And also subscribe and also visit RoboFlow to get the resources and try it out for yourself. Follow Nathan on LinkedIn. He drops some amazing stuff each and every day. So I'll put his link in the description as well. Bye.